Hello students, welcome back. In the previous video, we have discussed problem with typical distributed system. As we know that distributed system is essential for processing big data, but traditional distributed system was not feasible, was not suitable for big data. So Hadoop has been developed for processing big data. Now we will explore about Hadoop. Hadoop is a large-scale distributed batch processing infrastructure for parallel processing of big data on large cluster of commodity computers. In this one line of statement, there are multiple keywords. You have to understand that first. So, as you already know, large scale. So, big data problem deals with large scale problem that is very big in size in every aspect. So Hadoop is designed for a large scale problem, large scale data. It is distributed batch processing. Distributed, so obviously for solving big data problem, for processing big data, we need a distributed processing system. So it is distributed processing system. It is also a batch processing. Batch processing means it processes data, a collection of data, a group of data in one way without any intervention from user, without any interaction with the user. You don't need to be interfere in between. You don't have to be interact when processing is going on. Or simply it doesn't entertain streaming data. It only entertain batch data. So it is a distributed batch processing infrastructure for parallel processing. So obviously we know that if it is a distributed system, it obviously processes the things in parallel way. So if a system is distributed computing framework, then obviously it performs all its problem, all its task in a parallel way. So it is a parallel processing of big data on large cluster of commodity computers. So we already have discussed about what is cluster. Cluster is basically computers connected, multiple computers connected, and it appears as a single computers, work as a single computer. They work in a coordinated way. So it is a large cluster, means n number of computers can be added to the cluster. So it is scalable for larger problem. It is scalable for larger problem as well as for larger size of cluster. Means it is not limited to the number of computing devices in a cluster. You can form cluster with 10 computers, 5 computers, 100 computers, 1000 computers, 10,000 computers as per your requirement. So parallel processing of big data on large cluster. So cluster can be very large of commodity computers. So large cluster of commodity computers. So when you build a cluster, it always requires computers. So the required computers are commodity computers. Commodity computers means ordinary computers, not very high-end computers. You can use your laptop, you can use your personal computer to build a Hadoop cluster that doesn't require high configured, high-end computers. Commodity computers are simple, average computers. At the medium level computers, medium computing power computers can be used for making large cluster of Hadoop. Right? So Hadoop is a large scale distributed batch processing infrastructure for parallel processing of big data on large cluster of commodity computers. Now, Hadoop is an open source project of Apache. Apache is a open source foundation that supports development of Hadoop, which implemented Google's file system GFS as Hadoop distributed file system and Google MapReduce as Hadoop MapReduce programming model. So whole idea of Hadoop, its component its internal design was inspired on Google. Google's two system, Google file system was adopted and Hadoop distributed file system was designed, and Google's MapReduce technique computing framework has been adopted and Hadoop MapReduce programming model was designed. So this is how Hadoop has been evolved. This is the timeline year wise. In 2004, Google had published its paper on Google file system. In 2005, Google again published its paper on its MapReduce programming model. Then a nudge search engine was rewritten using MapReduce. Then Hadoop factor out of nudge project. Then it becomes a top level Apache project, and then it is wins TeraSort benchmark with 2009 seconds. It is an application of sorting that completed on Hadoop cluster within 209 seconds. So Hadoop was created by dog cutting. It is a consequent result of nudge search engine project of dog cutting. Initially, dog cutting was working on nudge search engine. He was making a search engine. Its name was nudge, and Hadoop is factored out from nudge search engine. So when dog cutting was working on nudge search engine, at the same time, Google published two papers on Google file system and MapReduce in 2003 and 2004 respectively, and that inspired dog cutting so much that he has rewritten the nudge project in MapReduce using Google file system and MapReduce. And after that, Yahoo supported his team and he started to work on Hadoop. And the name of Hadoop was based on a toy elephant, his son's toy elephant. And finally in 2006, Apache Hadoop project was started with support from Apache for development of Hadoop distributed file system and Hadoop MapReduce. So, what was the design principle of Hadoop that makes it so successful for big data processing problem? So let's explore it one by one. It provides a new way of storing and processing the data that we will discuss. Means storing data, because we are using Hadoop distributed file system for storing data, and processing the data we use MapReduce framework. So it's provided a totally new way for storing and processing. Hadoop is designed to provide computational power, that is MapReduce. So MapReduce is the computational power, means computational framework, and distributed storage, that is HDFS, at one place. So now, as I have discussed in previous lecture, that the problem with storage system is that storage system can handle huge volume of data, but it doesn't have analytical power. And the traditional analytical tool can process data, but they can only process limited volume of data. They cannot handle big data. Now Hadoop provides these two features at one place: computational power, analytical power, processing power in the form of MapReduce, and storage facility, that is in the form of distributed storage, that is HDFS, at a combined place. So Hadoop is initially, the Hadoop, when it has been developed, it is basically a combination of HDFS and MapReduce infrastructure. So what is the main principle of Hadoop? That is bringing processing to the data. Bringing processing to data. What does it mean? Its design principle, its design is based on distributing computational power to where the data is instead of moving the data. The movement of computation is always much cheaper than moving the data. So as we have discussed in previous lecture that in traditional distributed computing system we transport the data, means we have large volume of data, we partition the data in multiple chunks and then send the data to corresponding nodes for processing. That requires huge bandwidth and processing power, that increase the computation time. And that is the problem, that the traditional distributed system was not suitable for big data. But in case of Hadoop, we don't move the data, we don't transport the data. Data is already available on different nodes that form the cluster. We only move the computation power. The code, there are two things: code, that is computation, and data, that is big data, portion of data. So one way is to keep the common code and transport the data to the respective node, and the same code will be executed for different portion of the data. Another technique is simply design your code in such a way that we send the code to the different nodes where data is already resided. We don't need to move the data. So obviously that requires very less time. You have to only distribute the computation. How to distribute the computation? That is portion of different computation, portion of different codes. Same code be obviously same code is executed, but code is designed in such a way that on different nodes different portion of the codes will be executed. So we don't move the data, we don't disturb the data. Data is already available on different nodes with the help of HDFS, Hadoop Distributed File System. What we only do, we design MapReduce application, MapReduce code that is designed in such a way that data that is resided on different nodes will be executed. So obviously, if we are not moving the data, our system will work faster. Next principle is fault tolerance, and reliability is provided through replication. So we will explain this to the in more detail in consequent slides. But for now, as we have already discussed what is fault tolerance. So fault tolerance means when one job is splitted and executed in the form of multiple tasks, and suppose if one task has been failed, then you have to again resubmit and re-execute the complete job. So that is the fault intolerance. Fault was not tolerated, you have to again re-execute the job, the complete job. But Hadoop provides fault tolerance. How? If some nodes has been failed, has been crashed, or any task has been stopped or have some problems, is not executing, then simply we can re-execute only that task on some other node and without disturbing the complete job. And this is possible through replication. We will see what is data replication in consequent slide. Now, extremely scalable. What does it mean? It enables parallel application to run on a large Hadoop cluster of 1000 nodes and process petabyte scale of data. Obviously, the application that run are parallel application, large Hadoop cluster. So it is extremely scalable. Means suppose you have 1 GB data, 10 GB data, that can be solved by only 10 computers. Build a Hadoop cluster with 10 computers. Now suppose you have more data, even more larger data, You can form a Hadoop cluster of 100 nodes. So it is extremely scalable. As the data size grow, we can simply add more number of nodes. So cluster size can be increased or decreased according to the problem size, according to the data size. So that is the scalability. As the problem grow, we can handle the problem. We can increase our infrastructure. We can increase our computing power according to the problem, according to the data size. So Hadoop clusters is extremely scalable. You can add n number of nodes that will work very smoothly. Next point is make parallelism part of operating system. That is automatic parallelization, automatic data distribution, automatic workload balance. So in case of traditional distributed computing framework, it is the responsibility, it is the job of programmer that is writing the parallel code to make parallelization, how the code will distribute the data, how the code will distribute the computation, everything you have to program using MPI or some other framework. How data will be distributed, how workload will be balanced on different nodes. Suppose there are 10 nodes and you have divided your data or problems for different 10 nodes, and some nodes is getting executed, still getting executed, and some nodes has been already free up. So we can make the workload balance so that whole job can be completed within time. We can move workload from one node to another node. So that is workload balance. So in case of traditional distributed system, all these things have to be managed by the programmer. It is the programmer responsibility. But in case of Hadoop, the underlying system, what is the underlying system? The operating system. Hadoop is basically, you can say it as a data processing or data operating system. Means all these things, automatic parallelization, data distribution, workload balance, will be automatically managed by Hadoop. It is not the responsibility of programmer. You have to only write MapReduce code, means how to assign job, how to design your code for the problem using MapReduce framework. We will discuss it when we come to explore MapReduce framework, how to write MapReduce code. But when we write MapReduce code, we don't think about all these things, automatic parallelization, data distribution, workload balance, because all these things have been handled by the Hadoop operating system, Hadoop data operating system. Large files preferred over small. Obviously, Hadoop is not designed for small files, small data. It is suitable for big data, large scale data. So if you are executing Hadoop for small file, small scale data, then obviously its performance will be not significant. It will take much larger time. So this is a general diagram that demonstrates how Hadoop works with its two core components, Hadoop distributed file system and MapReduce. So initially, big data that needs to be processed, that needs to be analyzed using Hadoop, has been outside of Hadoop distributed file system. So we call it as a local file system, right? So initially big data is in local file system. Now we copy big data from local file system to Hadoop distributed file system. When this data has been copied or moved from local file system to HDFS, Hadoop distributed file system, it will be automatically splitted into number of blocks of data, multiple blocks. And for each blocks, there will be map operation. MapReduce code will be applied on these bulks of data, these chunks of data. So for each block, map operation will be applied on each block. And then output of map operation will be sent to the reduce operation. And reduce operation, same reduce operation will be applied to the output of map operation. And finally, the final result will be stored here. And then you can get final result from HDFS to local file system. So you can copy from local file system, HDFS to local file system. So this is general diagram that shows how how HDFS and MapReduce inside Hadoop works together. So in next video we will discuss each components, HDFS, how Hadoop distributed file system works, how we do write code using MapReduce framework. For now, thank you.